Hi all, in this video I am going to explain how to draw the root locus plot for g of s into h of s equal to k divided by s into s plus 1 into s plus 3. First of all, I am going to explain the step number 1. So what is the step number 1? Find the number of open loop poles and number of open loop zeros. How to find the number of open loop zeros? Numerator polynomial equal to 0, we get number of open loop 0. Here in the numerator, there is no s term, so number of open loop zeros are 0. Open loop zeros equal to 0. And number of open loop poles. Equate the denominator polynomial to 0, we'll get the number of open loop poles. S into s plus 1 into s plus 2 equal to 0. S plus 3. So what are the values? S is equal to 0, minus 1 and minus 3. So these three are the number of open loop poles. There are no finite open loop zeros, so that all three zeros are at infinity. Therefore, there are three asymptotes. The three branches of the root locus are start at open loop pole at k is equal to 0 and ends at open loop 0 at k is equal to infinity. How many root locus branches for this given transfer function? Number of branch equal to number of poles. There are three numbers of poles are available, so number of branch in the root locus is 3. So total number of branches in the root locus 3. Then for the root locus to exist at any point in the S-plane, the phase angle condition must be satisfied. That is g of s into h of s equal to plus or minus 2q plus 1 into pi must be satisfied. These conditions can be satisfied at any point on the real axis only if the total number of open loop poles and zeros to the right of the point is odd. Okay, so where the root locus exists, that is important. The total number of open loop poles and zeros to the right of the point is odd. Now I am going to plot the number of open loop poles and also root locus branch. First of all, I am going to mark the axis. Here this is sigma real axis and this is the j omega axis, that is the imaginary axis. What is the transfer function given? G of s into h of s equal to k divided by s into s plus 1 into s plus 3. First, I am going to mark the poles. Here first, mark the poles, that is 0. The first pole is 0. Second pole is minus 1. And third one is, so in what point the root locus exists? The number of poles that is right to the point is odd. That point root locus exists. Here I am going to consider a point here. Here consider the point P1. Number of poles right to the point P1 is odd. So the root locus exists here. In this point, the root locus exists. So in this point, the root locus exists. So root locus starts from the point minus 3 and ends at k is equal to infinity. Next, I am going to consider another one point P2. Here see, number of poles right to the point P2 is odd or even? Here even. Even number of poles that is right to the point P2. So there is no root locus exists between -3 and -1. Next I am going to consider the point here between -1 and 0, point number 3. See, number of poles right to the point P3 is odd number, only one number. So root locus exists between -1 and 0. So root locus exists between -1 and 0. Here one of the root locus is from k is equal to 0, the pole -3, and k is equal to infinity. Next find out the another two more root locus path. See, the root locus path starts from open loop poles and ends at open loop zeros at infinity. Okay, this is the root locus plot. So 1, 2 and 3. 3 root locus plots. This point is known as breakaway point. Here I am going to find out the breakaway point first. And next, using the root stability criterion, I am going to find out at what point this root locus crosses the imaginary axis. That also I am going to find out. Okay. In addition to that, I am going to find out the asymptote and centroid. See, this is the asymptote angle. The equation is theta q equal to 2q plus 1 divided by 3 minus 0. 3 minus 0 means number of poles minus number of 0. Q value is equal to 0, 1, 2. This is 3 minus 0. The total number is 3, no? It is start from 0. Q value start from 0, 1 and 2. First substitute the value Q is equal to 0. So pi divided by 3, 190 by 3, that is 60. Next Q is equal to 1. 3 pi by 3, 190. And next 5 pi by 3. 2 into 2 plus 1, 5 pi by 3 is equal to 300. So 3 asymptote angle 60, 180 degree and 300. And next find out the point of intersection of the asymptote on the real axis is called centroid. Here how to find out centroid. Centroid is sigma, sum of real parts of poles minus real parts of zeros divided by number of poles minus number of zeros. Number of real parts of poles, that is 0, minus 1, minus 3. Have to put in the first, minus sum of zeros equal to 0. Number of poles 3, number of zeros 0. The answer is minus 1.33. So next I am going to mark the centroid and asymptote angle in a graph. Here minus 1.33. So this is minus 1.33. After finishing the minus 1.33, next draw the asymptote angle. The asymptote angle is 60 degree, 190 degree and 300 degree. I am using the pro circle to mark the asymptote angle. So I have to place the pro circle, the middle point in the centroid. Then I am going to mark the three angle 60 degree, 190 degree and 300 degree. First I am going to mark the 60 degree. So 60 degree is marked. Then I am going to mark the 300 degree. The 300 degree also have marked. Then I am going to mark the 190 degree. I am going to mark the 190 degree over. And after finishing this, I have to connect the centroid with this angle. Centroid is connected the angle. Here also I am going to connect this. Okay, these are the three angles. Next I am going to mark the angle. So the first angle, that is 60 degree, and next angle, that is 180 degree, and the third angle, that is 360 degree. So these three angles have to mark. After marking these three angles, next I am going to find out breakaway point. Why I am going to find out the breakaway point? Then only I can find out the root locus plot. One of the root locus is over, that is minus 3 to infinity. So k is equal to 0 to infinity. Starts as minus 3 and ends at infinity. Another two poles should be between 0 and minus 1. Okay, how to find out the breakaway point? So breakaway points are given by the solution dk by ds equal to 0. So first of all, we are going to find out 1 plus g of s into h of s should be equal to 0. 1 plus k divided by s into s plus 3, s plus 1 into s plus 3 equal to 0. From this, how to write s into s plus 1 into s plus 3. So s square plus add this 1 plus 3, that is 4s plus 3 into 1, 3 equal to 0. K plus. So k plus s into s square plus 4s plus 3 equal to 0 or k plus s cube plus 4s square plus 3s equal to 0. So k is equal to minus of s cube plus 4s square plus 3s equal to 3s. Next I am going to find out differentiation of k with respect to s. So what is answer? 3s square plus 8s plus 3 equal to 0. Then put minus b plus or minus square root of b square minus 4ac. So minus 8 plus or minus square root of 64 minus 4 into 3 into 3 divided by 2 into a. So 2 into 3. So we get the answer minus 8 plus or minus square root of 28 divided by 6, that is minus 0.451 or 2.28. With two values we got 0.451 and 2.28. Minus 0.451 minus 2.28. Okay, see which one is the breakaway point? The breakaway point is between 0 and minus 1. So which one is correct? 0.451. That is in between 0 and minus 1. So I have to mark the breakaway point here. So this is the breakaway point minus 0.451. After finishing the breakaway point, I am going to find out the root locus crossing the point in the imaginary axis. What is the point of crossing the root locus in the imaginary axis? Okay, next I am going to take the similar equation k plus s into s square plus 4s plus 3 equal to 0. So s cube plus 4s square plus 3s plus k equal to 0. Here my aim is to find out the value of k and also to find out the crossing point of root locus in the imaginary axis. I am going to apply the root criterion. So put s cube, s square, s power 1, s power 0. So first put the value 1 and 3 odd values. Then put the even value 4, then k. Have to cross multiply here 12 minus k by 4 and k. What is the condition for stability? The first column of the root array should be positive. So k should be greater than 0 and 12 minus k by 4 should be greater than 0. So 12 minus k is greater than 0 and k is less than 12. So two conditions, one is 0 and another one is k is equal to 12. So using this, I am going to find out the value of s. What is the value s? S is the crossing point in the imaginary axis. So for this, I am going to take the second row of the root array. So 4s square, corresponding equation is 4s square plus k is equal to 0. So what about k? K is equal to 12. Already we got the answer. So s square equal to minus 3, s is equal to square plus or minus j square root of 3. The answer is plus or minus j 1.73 or plus or minus j 1.7. Okay, next I am going to mark this point in the imaginary axis of the root locus. The value is plus j 1.73 plus or minus j 1.73. Here I am going to take this is 1 and this is 2. So the value 1.73 should be here. This is the 1.73. So I am going to mark 1.73. 1.73 should be here. Here also 1.73 should be here. Next, what I am going to do, I am going to mark the root locus plot. Here, this is the root locus that crosses the imaginary axis at 1.73 plus or minus j 1.73. So this is the point that is the breakaway point. This is breakaway point. Okay, these are about the root locus. Then the direction of the root locus here, this is towards the breakaway point and here away from the breakaway point. So this is the one of the locus, this is the next locus, the third locus. So 3 numbers of root locus branch. That's all. This is the way to draw the root locus diagram. Thank you. Have a nice day.